we're going to take a look at multiplying polynomials. So we're going to take what we learned previously in regards to multiplying with exponents, and we are actually going to apply it to multiplying with polynomials. So polynomials means we have more than one item times one item. So some of these could be a monomial times a binomial, but most commonly you're going to find a monomial times a binomial or a binomial times a binomial. In some extreme cases, we're looking at trinomials times trinomials, but the process remains the same regardless of how many terms we have in our problem. So how do we multiply with polynomials? Well, first things first, we multiply what we have that's the same. Number one, we multiply the coefficients. Then we multiply the powers with the same base by adding the exponents. And if we have parentheses, we have to distribute. So what does it look like? Because those are kind of confusing instructions here. Multiply coefficients, multiply powers by adding exponents, and distribute if we have parentheses. So if it's a monomial times a monomial, and we can tell what we have based on the number of terms in our problem. So if I take a look at our first problem here, negative 5x squared y cubed times negative 2xy squared. What we have to do is, here we have a monomial times a monomial, nothing major. We're going to multiply things that are essentially the same thing. So number times number, letter times letter. In our case, we have negative 5 times negative 2. And if I use the rule of math, negative times negative makes positive. 5 times 2 makes 10. Now we have x squared times x. Again, if we are multiplying like bases, we're going to add our exponent. So if I think about it, the x here has an exponent of 1. So the base being x, and I add 2 plus 1 to get x cubed. And then we have y cubed times y squared. So the base being y, I add my exponents, 3 plus 2 gives me 5. So there's my answer, 10x cubed y to the 5th. Now if I look at number 2, it's set up a little bit differently. This one I have negative 5 times 4m minus 6n. So here we have a monomial times a binomial. So one guy times two guys inside parentheses. This is where distribution comes into play. What distribution means is I take what's on the outside of the parentheses and multiply it times everything inside. So this negative 5 will multiply times the negative 4m times the 4m, and I will also multiply it with the negative 6n. So negative 5 times 4m, negative times a positive makes a negative. 5 times 4 is 20. M comes along for the right. So I took care of the 4m. And now I have the negative 6n. So negative times negative makes a positive. 5 times 6 is 30. And n comes along for the right here. So now I multiply the negative 5 times the negative 6n. I check to make sure that there's no like terms that I can combine. I got the letter m, the letter n. So I am done. I can't do anything further than what I have here. Number 3, again, we have a monomial times a binomial, one term on the outside times two terms inside parentheses. Again, I'm going to use distribution here. So this negative 5c squared is going to be multiplied times both items inside parentheses here. So I'm just going to take it one at a time. So first thing is the negative 5c squared times 15c. Negative 5 times 15, negative times positive makes negative. 5 times 15 is 75. And now I do the c squared times the c again. No exponent means we have an exponent of 1 on this c. Base is c. 2 plus 1 gives me exponent of 3. So I took care of the 15c. And now I multiply the negative 5c squared times the negative 4c squared. Negative times negative makes a positive. 5 times 4 is 20. And then c squared times c squared, the base being c, 2 plus 2 exponent gives me a new exponent of 4. Last but not least, I check to make sure that there is no like terms. C cubed, c to the fourth. Because they have different exponents, I cannot add these two numbers together. So we are done here. In the fourth problem, we have 5 times d minus 3 plus d squared minus 10d on the outside. So here we have a monomial times a trinomial. So one item times 3. Process remains the same. Whatever is on the outside will be multiplied with everything inside. So the 5 times the d, we get 5d. 5 times negative 3 minus 15. And then 5 times the d squared plus 5d squared. And then because minus 10d is on the outside, I cannot multiply it. I'm just going to leave it as part of my problem here, minus 10d. Next step, we want to combine like terms. So we have 5d minus 10d. When we do that, we get negative 5d minus 15 plus 5d squared. So technically that is the completed answer because we cannot combine like terms. We got the letter d, we got a solid number, and we have d squared. However, if we wanted to put this in simple standard form, I would just rearrange it so that the highest exponent comes first. So 5d squared minus 5d minus 15 would be the correct simple standard form of the answer. So that is distribution, monomial times any number that we can think of, monomial times monomial, monomial times binomial, and a monomial times trinomial. Distribution remains the same. What's outside is multiplied with everything inside. Now, if we move on to, in this case, a binomial times a binomial, 2 items times 2 items, we still use what's known as distribution. If it's 2 terms, there's a simple acronym you can remember, but distribution remains the process. So this acronym only works if it's 2 items times 2 items. So binomial times binomial. And it's called FOIL. And the acronym stands for first, outside, inside, and last. So basically what it means is first item times first item. In this case, it would be x times x because they are the first items inside the parentheses. So first item times first item, x times x, is going to give me x squared. Outside, so this means what is on the outside of the parentheses. So if I think about it, the x is kind of on the it's on the outer edge. So x times the 5, because that's on the outer edge of the parentheses. So x times 5 is going to give me plus 5x. Inside stands for the 2 items that are on the inside part of this problem. So the 2 middle terms, so 4 times x, since they're on the inside, the middle part of it, just smush them together, plus 4x. And then last, so the last terms in the parentheses. So 4 is the last term in the first parenthesis, 5 is the last term in the second parenthesis. 4 times 5 gives me plus 20. What I'm going to do now is combine the like terms. Here we see we got 5x and 4x. Because they're the same thing, I can add them together. So x squared plus 9x plus 20. So that's the first method, if you want to use distribution. The second method is the box method. I'm not a fan of this. It's not how I learned it. It's a little bit more, it's a longer process, and because processes are longer, it leaves more room for error. But if you use the box method, basically what you do is you create a giant rectangle and you split it into 4 sections because we got 1, 2, 3, 4 terms. So we split it up, so we have x plus 5 and then x plus 4. And what we're going to do is we're going to multiply this x times both terms up here. So x times x is going to give me x squared. X times 5 is plus 5x. Next up, we take the 4 and we do the same thing. The 4 gets multiplied times x, 4x, and then the 4 times 5 gives me plus 20. And again, a positive 4 times positive x is a plus. Notice now that our middle terms are the same thing, so we can circle them, highlight them, whatever you want to do. I tend to circle, so because they're the same, I can circle them. Whatever's on the outside, I leave part of it, so x squared. I add my terms 5x and 4x plus 9x, and then plus 20 is on the outside of that circled bit, so we get x squared plus 9x plus 20. So again, both options are available to you, whichever method you prefer. I prefer distribution myself, but if you like the box method, you are more than welcome to use that. Again, so I'll flip-flop between the two methods. I'll show you what the box method looks like and distribution looks like on these problems. If I take a look at this first problem, x plus 2 times x plus 3, distribution means I will distribute the x first, so x times x and x times 3. So x times x is going to give me x squared. X times 3 is plus 3x. And then once I'm done with the x, I will distribute the 2. 2 times x and 2 times 3. So we have plus 2x. 2 times 3 gives me plus 6. Next up, I'm going to combine the like terms. So I see here in the middle, I got plus 3x plus 2x. X squared is on the outside. I add the positive 3 and the positive 2 to get plus 5x. And then plus 6 is on the outside. So that was using distribution. Number 2, I'll use the box method. I got x minus 4 times x plus 2. So here I need to create a box. One of these is x and negative 4, so I can split it this way. And then the other box is x and negative 2, and I can split it that way. So now I have my boxes, and I'm going to multiply the x times x, in which case I get x squared. X times negative 2 gives me negative 2x. Negative 4 times x minus 4x. And then negative 4 times negative 2. Negative times negative makes a positive. 4 times 2 is 8. Here we see that we have x's in the middle, so I can circle them. I have x squared. I combine negative 2x minus 4x to get minus 6x, and then plus 8 is on the outside. So these are my answers for 1 and 2. Number 3, we got 2x plus 5 times 3x minus 4. I'll use distribution on this one. So this means I will distribute the 2x. So 2x times 3x, I'm going to multiply the number. 2 times 3 gives me 6. X times x is x squared. And then I'll do 2x times negative 4. 2x times negative 4. 2 times negative 4 gives me minus 8. X comes along for the ride. And then we distribute the 5. So 5 times 3x, so we get plus 15x. 5 times negative 4, positive times negative makes negative. 5 times 4 is 20. And we're going to combine the like terms, the middle terms. So we have 6x squared plus 7x minus 20. So again, that's the distribution method. If I were to use the box method, for instance, in number 4, box method means I need a box. And I'm going to put one parenthesis along the side and the other parenthesis along the top. So along this side, we got 2w minus 1. And then the other one is 3w squared and plus 1. And I'm going to separate it so that way there we kind of create a barrier. So now we have the 2w, the minus 1, the 3w squared, and the 1 vertically there. And I'm going to multiply every item together. So we got 2w times 3w squared. 2 times 3 gives me 6. W times w squared, we add our exponents, so now I have 3, so w cubed. 2w times positive 1, so that's a plus 2w. Negative 1 times 3w squared, I just changed the sign, so negative 3w squared. And then negative 1 times 1 minus 1. I look to see if we have any common terms. We got w cubed, w squared, minus 1. So there are no like terms, so I'm just going to put this in order from highest exponent to lowest. 6w cubed being the highest, so that comes first. Then w squared minus 1. W squared has the next one, so minus 3w squared. Plus 2w minus 1. So we have it in order, simple standard form, highest exponent to lowest. Now the next one, we have a binomial times a trinomial. So we're still using distribution. So I'll take the x and I have to multiply it times everything inside the other set of parentheses. So I'm actually multiplying this x times 3 items. So x times x squared, x cubed, x times negative x minus x squared, and then x times 1 plus x. And then I distribute the negative 1. Again, I multiply times all 3 items in the other one. So negative 1 times x squared, so minus x squared. Negative 1 times negative x, so plus x. And then negative 1 times 1, minus 1. I look for common terms, so same base with the same exponent. So I see I have a negative x squared and a negative x squared. I also have a positive x and a positive x. So those I can combine together. So notice I highlighted in the same color. Those are the ones that I can combine together. So x cubed being on the outside. Next highest exponent would be the 2. So I'm going to combine my x squared. So negative x squared minus x squared. I'll get minus 2x squared. X plus x gives me plus 2x. And then minus 1 is on the outside. So what does the box method look like when I have a trinomial times binomial? Well, I still do the same thing. I have to create a box, a rectangle. Might be a little bit bigger this time around. The 1, we have the 3 terms. We have y squared, we have a positive 2y, and we have a minus 1. And the other one, we have a y and a positive 1. So I'm going to split it up between the terms. So now we have 6 boxes to work with. I'm still dealing with multiplying everything times everything. So I might as well take the y and multiply it times everything up here. Y times y squared will give me y cubed. Y times 2y will give me positive 2y squared. And y times negative 1 just gives me minus y. And then I'm going to do the same thing with the 1. I'm going to multiply 1 times everything. Identity property of multiplication says that I multiply anything times 1, I get the same thing. So 1 times y squared is just going to give me y squared. 1 times 2y is just going to give me positive 2y. 1 times negative 1 is just going to give me negative 1. Next up, I'm going to circle the items that are going to be the same. So y cubed, no other y cubes in my boxes, so I'm going to leave it be. Y squared, I see I have y squareds here. And I also have y. So I can combine those guys together. So y cubed, I can't do anything with. 2y squared and y squared, if I add them together, I get 3y squareds. 2y minus y just gives me 1y, and then minus 1 on the outside. And the last one we'll do, which is lengthy, is a trinomial times a trinomial. philosophy remains the same. I'm still using distribution or the box method, whichever you prefer. If I use the box method, I would end up with 3 across and 3 down. Distribution, I follow the same rule. Each item gets multiplied by everything. So we might as well start at the beginning. So we'll multiply the x cubed times everything inside the other set of parentheses. So x cubed times x cubed. Separate bases, we add our exponents. So x to the 6th. X cubed times the negative 5x. Well, we have minus 5. Add our exponents. 3 plus 1 gives me 4. And then x cubed times positive 2. I just put the letter and the number together. So plus 2x cubed. Once I'm done with that, I distribute the 2x squared. So the 2x squared times the x cubed times the negative 5x times the 2. So 2 times negative 5 gives me minus 10x to the, wrong one, got ahead of myself there. 2x cubed times 2x squared times x cubed plus 2x to the 5th. After we add our exponents, now we can multiply the 2x squared times the negative 5x. This is where I get the minus 10. X squared times x gives me x to the 4th, or x to the 3rd. 2 plus 1 gives me 3. And then 2x squared times 2, so plus 4x squared. So I've taken care of the x cubed and the 2x squared now, meaning all we have left now is the negative 6, in which I will distribute the negative 6 times everything. Negative 6 times x cubed gives me minus 6x cubed. Negative 6 times negative 5 plus 30x. Negative 6 times 2 minus 12. Now what I have to do is go through, see if we got any like terms, highlight them, or circle, use different shapes. So x to the 6th, do we have any x to the 6th in our problems? Nope. So x to the 6th is being written first. So x to the 6th is going to be part of our answer. So I took care of the x to the 6th. Because we want this in simple standard form, we're going to look for the next highest exponent. So after 6, it'd be 5. So 4, 3, 5, 3, 2, 3, 1. So 2x to the 5th. Do we have any other x to the 5ths in our problem? The answer is no. So plus 2x to the 5th is going to be part of our answer. Next up, I look for exponent of 4. Here we see we got negative 5x to the 4th. Do we have any other x to the 4th in our long expression here? The answer is no. So again, it's going to be part of our answer, minus 5x to the 4th. So after 4, we look for 3. I see we have a different color here. We got 2x cubed minus 10x cubed minus 6x cubed. So we actually have 3 that we can combine here. So when I do the addition here, because they're all the same base, I just add our numbers together. So 2 minus 10 minus 6, I'm going to get negative 14 x cubed. So I took care of my x cubes. After 3, I look for the exponent of 2. Here we have 4x squared, and I don't have anything else left. Actually, I take a look. I don't have any other like terms. 4x squared, 30x, minus 12. They're all different terms because that's an x squared. That's just an x. That's a solid number. We can't combine anything that's left. So I'm going to put what we have left. Plus 4x squared plus 30x minus 12. If I cross them off, I see I have used every term that I have in my long expression, meaning this is our very lengthy, very long answer to this particular problem. So again, trinomial times a trinomial, you could end up with a very lengthy answer. So that's using distribution on the trinomial times the trinomial. Using box method, instead of 2 rows and 3 columns like we did in number 6, you're going to have 3 rows and 3 columns, and you're going to end up with this same answer. And that is multiplying polynomials using either the distribution method or the box method. Again, when it comes to solving these problems, it doesn't matter which of the two you use. It's your choice, and you just want to pick the one that you are more comfortable with in order to come up with the answer.